Hey, we're at gotomath.com. Click on the algebra. Let's go down to factoring trinomials. A trinomial. So tri means three, right? And there's three monomials here. And that makes up a trinomial. So there you go. All right, even though we might have done some of these just like that. So we got x squared plus 13x plus 30. It says factor the expression. So I guess we're going to get more practice. X squared plus 13x plus 30. Can we remember that? X squared plus 13x plus 30. Right. Okay, so we're going to go ahead and write these factors. So we know that there's going to be an x here and an x here because x times x is x squared. Now, here's the trick. We got a 30, and so what you're going to want to do is think of, let's see, 15 and 2. 15 times 2 is 30. Now, we need to get a 13 here, and I know that 15 minus 2 will give us a positive 13. So if I said a positive, but that's a positive. So you couldn't put a 15 here and then minus 2 here because then you'd end up getting a negative 30. So there's something fishy about this problem. Let's see, let's look here. We can break that up as to 3 times 5. And let's see, here's 3 and 10. This was a tricky one here. 3 and 10, if we add those together, we get 13. And when we multiply them, we get 30. So that was that could have been tricky there. Okay, so let's put a 3 here and then a 10 here. How's that? We add them, we get 13, and we multiply 3 times 10, we get 30. We get 30. So let's just click on that. Yep, that's it. X plus 3, x plus 10. Now when you go to type it in up here, you notice this number is smaller than this number. So the way I'm kind of working this is you'll type it in just like that. Okay, the smaller number first and then the larger number. All right, even though that's x plus 10 times x plus 3, it's also an answer, but I don't have all those answers programmed in. Okay, so we're over here at gotomath.com studying some algebra. Looks like we're factoring trinomials, and see you in the next problem. Hey, we're over here at gotomath.com. Click on the algebra. Let's go down to factoring trinomials, and we're looking at 1.2. So we have x squared plus 13x plus 36. Let's factor the expression. X squared plus 13x plus 36. So because this is an x squared, we know that both of these factors are going to start with an x. And I'm not exactly sure what happened there. Something crazy. Right, because x times x is x squared. Now we're looking for two numbers, and when we multiply them together, okay, we get 36. You can think of the two numbers as being like a times b is 36, and then when you add a plus b, you get 13. You get 13, okay? Think of it that way. Well, what I'm going to do here is let's see. We know that 6 times 6 is 36. Right, but when we add them, we don't get 13. But it's close, though. It's close. What if we let's see, let's break this up into 2 times 3 here. And then we got a 6. Let's see. 6 times 3 is 18. And so that's not going to work. 2 times 2. Well, let's do this. So our prime factorization is going to be 2 times 3 times 2 times. Okay, what about, did I do 6 times 4? No, 9 times. Let's see, 2 and 9. 9, 10, 11. Wait a minute, something's fishy here. 2 times 3. 2 times, that should be a 4 there. Okay, sometimes these things can be puzzles. Alright, 4 times 9 is 36. And when we add, we get 13. So you might have been able to do that a whole lot faster. I'm kind of under pressure here. Okay, 4 plus 9 is 13. And 4 times 9 is 36. Alright, let's click on the answer there. Yep, x plus 4 times x plus 9. Alright. Okay, so we're over here at gotomath.com. Come by, practice, see you in the next problem. Hey, we're over here at gotomath.com. Click on the algebra. Let's go down to factoring trinomials, and we're going to be looking at 2.1. 2.1. Okay, so we might have done some of these already, but right, you can't get enough practice. This is stuff that you're going to see over and over again in the future. Factor the expression. So I'm going to go ahead and write this one down here. This is 2.1, right? So we got 5x squared plus 15x plus 10. Now things can get tricky when the leading coefficient, which is 5, when this leading coefficient is a number other than 1, then things get a little tricky. But it's not going to be too bad, because the factorizations of 5 is just 1 and 5, and that helps out. Alright, so we have 5x squared plus 15x and then plus 10. Okay, so we're going to start with a 5x here, because we know that 5x times x is going to be 5x squared. All right. Now we're looking for two numbers still, that two numbers, and we multiply them together, we get 10. Now the good thing about 10 is the factorizations. Well, I say we can factor that as into, well, I say factor. We can use 1 and 10. How's that? Because 1 times 10 is 10. In other words, A could be 1, B could be 10. But what are some others? Well, 2 and 5. Right, 2 and 5, 2 times 5 is also 10. So these are some these are going to be our possibilities, okay? It's either going to be 1 and 10, or possibly 10 and 1, or 2 and 5, or 5 and 2. Right? But here's the trick here, and that is we got this 5 right here, okay? So in other words, we're going to take this 5, we're going to multiply it by this number, and then add it to this number to get this guy right here. And I'm going to put a 5 here. Sometimes it's just trial and error. Okay, let's take a look at this. We know that 2 times 5 is 10. We also know that 5 times 2 is 10, plus 5 is 15. And so we could say plus, and then plus here also. See that? Alright. So let's go over to the board and check that out. And I also see something else that I need to add to all this. So we have 5x plus 5 and x plus 2. Whoa, x plus 1. This can only have one solution here. Let's see. I mean, this is a solution. Now that I think about it, 5 plus 10 is 15, and 10 times 1 is 10. Did I do this right? 5 times 2 is 10, plus 5 is 15. See, if you multiply 5x times x, you get 5x squared. I've never realized that these things could have more than one solution. 5x squared, and then 5 times 2 is 10x, and then plus 5x, and then we have 5 times 2 is 10, and so we end up with 5x squared plus 10x, or whoops, let's erase that. Okay, plus 15x, and then plus 10. Now, I think what's going on here is, there was something I was going to add to this. You notice there's a 5 here and a 5 here. Well, we could actually factor a 5 out. And this is what we're going to be left with over here. 5 times x plus 1. Right? And then, of course, you'd have x plus 2. And that would be completely factored. Alright? That would be completely factored. Now, this is one of them, obviously. And, of course, you could factor a 5 out of all of this. And, anyway. Let's go back here, though. Yeah, okay, well, I guess we got more than one solution here. But if we were completely factoring this expression, we would want to pull the 5 out, right? And it'd be left with x plus 2. And my guess is up here in the checkbox, this is going to be the answer that you're going to want to put up in the checkbox, all right? That's if you want to do that. Okay, well, we're over here at gotomath.com getting it figured out, and I'll see you in the next problem. Okay, we're over here at gotomath.com. Let's go down to factoring trinomials, and we're going to be looking at 2.2. 2.2. Okay, so I'm going to write this down here. We got 12x squared plus 7x and then minus 5. Alright. $12x squared plus 7x minus 5. Alright. Now the thing about this coefficient here, in the previous problem there was a 5 here, and so that's really all we needed to deal with. However, there's a 12 here, and that means that this thing has got more combinations than Taco Bell. How do you like that? Yeah. In other words, these coefficients, it's going to go in front of x here. Okay? This could be a 12, and that could be a 1. So we got to look at this. We have 12, right? And so we could have a 1 and a 12, or we could have a 2 and a 6, or possibly a 3 and a 4, and sheesh, what else is there? Let's see, 6 is 4 is 2 times 2, so I guess those are it. So this can be a 12 and a 1, a 2 and a 6, 6 and a 2, a 3 and a 4, 4 and a 3. Oh my gosh. So what happens is we end up doing this trial and error thing. Now, good news is there's just a 5 here, and so that means that this number right here and this number can only be a 1 and a 5, a 1 and a 5, or a 5 and a 1. You see that? So that's the good news. And I'm just going to put a number here and then put 1 here, put a 5 here. Okay? Now this is a minus sign right here. So one of these guys has to be minus and one has to be plus. Yeah. Okay. So here we go. Let's try, okay, well, we know that a 12 couldn't go here because 12 times 5 is going to end up being 60, and that's way too far away from what this is here. Okay. However, and if we put a 6 here, 6 times 5, that's going to end up being a 30, and that can't be it either. But what about if this were a 2, and 2 times 5 is 10, and this were a 6. No, wait a minute. I've lost. Let's see. Okay. A 2 and a 6 here. So 2 times 5 is 10, and 6 is 10 and 6 is a difference of 4. That's not it. What about a 3 and a 4? A 3 here, 4 here. 3 times 5 is 15, and then a 4. That would be 11. A 4 is 20. Yeah, that's not it either. Okay. I should have, yeah. Let's put a 5 here and a 1 here. Okay. Let's just start putting some numbers in here, I guess. Let's do this. So 3 times 1 is 3, and then 5 times 4 is 20, and 20 and 3, that's not going to work, is it? Okay, so let's put, whoops, I didn't mean to erase both of those. Let's just give it a little bit of space here. Alright, let's put, did I put a 4 here and a 3 here? So 4x, let's see, this is going to be a 4 and then a 15. I think I already said that, 4 and 15, that's not going to work. 4 and 15, no. Okay, let's erase those guys. I think we're narrowing it down now. A 2 and a 6. How about a 6 here and a 2 here? 6 times 1 is 6 and 10. But 6 and 10, you can't get 7 either. Wow. That's what I'm talking about, man. I never was good at this. I'm going to put a 12 here. How's this? And then just a 1 goes here. So this is 12 and 5. Hey, I think that might be it. 12 minus 5. What's that? That's going to be 7, isn't it? Hey, I think I got it. So you can kind of see the struggle here. Let's see. We're going to put a minus here and a plus here. How's that? So 12 times, let's see, 12x times x is 12x squared, and then 12x times minus 1 is negative 12, and then, oh, wait a minute, I got my signs backwards, didn't I? Wow. Minus and a plus. Okay, so 12x times 1 is 12x, and then minus 5x is going to be 7x. That's ridiculous. Okay, 12x minus 5. That's what you just got to start plugging numbers in, you know, going through all the possibilities there. So we got 12x minus 5 and x plus 1. That was exhausting. I don't think I've ever spent that much time on a problem. 12x minus 5 and an x plus 1. So I don't have this stuff worked out in advance. X plus 1. Okay. Doing it right here on the fly. Alright, so we're over here at gotomath.com. We are practicing because practice makes perfect, and I'll see you in the next problem. Alright, we're over here at gotomath.com. Click on the algebra. We are pulling our hair out over here at factoring trinomials. Let's do 3.1. Oh my god, those are big numbers. That's better. A little bit. Yeah, we'll do that. Alright, so we have 5x squared plus 45x plus 90. I better write that down. 5x squared plus 45x plus 90. Alright, so hopefully we can get this done here in just a second or two. I like the last problem. That was terrible. 5x squared plus 45x plus 90. But I need to show you how to struggle through it. That's important. Right? I mean, if I had the problems already made up and I was just writing down what I had made up, you don't learn anything from that. Okay, well, we know this has to be a 5 here because 5x times x is 5x squared. So that's a good thing. Now, something else. Let's talk about the signs here just for a second. This positive sign basically means there's either a minus here and a minus here, because a negative times a negative is a positive. What you got to keep in mind is this number right here has to be positive. And that's not possible, because if this number was multiplied by this number and then added to this, right, we'd end up getting a negative if both of these were negative. Okay, so it looks like that this will have to be positive, and this is going to also have to be positive. All right, now let's take a look at 90. What do we got here? Well, it could be 1 and 90, and I said 90 and wrote 20. That's kind of weird. That is totally bizarre. Okay, so in other words, if this were a 90 and this were a 1, you would have 5 times 1 plus, no, that's not going to work. We got to get 45 here. And it's basically, we're going to be adding two numbers together to get 45. So let's break this 90 down. We know that 90 is 2 times 45. We do know that. Now, if I put the 2 here, and a 45 here, that's not good. That's going to be more than 45, isn't it? So we're going to need to really bust this thing up. So let's look. We got 5 times 9, right? 5 times 9 is 5 times 9, 45. 9 times 5 is 45. Yeah. Man, I'm starting to worry about my brain. Slightly. Okay, well, let's see. What about 10 and 9 then? What can we do with that? If I put a 10 here, that would be 50. Then no, that's not going to work. But if I put a 9 here, that would be 9 times is 45, and then that's not going to work either. So let's keep breaking this thing down. There's a 3 and a 3 and a 10. Okay, what about 13 and 3? Wait a minute. That's not right. Hold everything. Okay, what about 3 times 3 is 9. What about 30 and 3? If I put a 3 here, I think this might be it, and then a 30 here, right? So 5x times 3 is going to be 15, and then plus 30x, there you go, is 45. Okay, I think we finally found it. Now, there's something else that needs to be said here, that if we were completely factoring this, we'd want to pull out a 5 out of here. And I don't think we're really completely factoring. This is, what's that, 6 but it needs to be stated. It needs to be stated that if we were completely factoring, we'd want to factor out of 5. Okay. And wow, I actually do factor out of 5. And one of the problems earlier, I didn't do this. That's disturbing. Okay, well, I actually factored out a 5 out of that. 5 times x plus 6, x plus 3. Of course, I got the smaller number here first and then the larger number. Okay, well, there it is. I don't know what else to tell you. I did factor out a 5 in that problem. All right. So we're over here at GoToMath.com. About to fall asleep. And see you in the next problem. We're at GoToMath.com. Click on the algebra. Let's go down to Factoring Trinomials. And we're looking at 3.2. Somebody's looking at 3.2. What are we doing here? I don't know. Let me write this down. And I just thought of something in the last problem. I see it in this problem, and we're going to definitely mention it and implement it. Yes, we are. So we have 2x squared, and I think that's what I meant to do, but forgot about doing it, making life a whole lot harder than what it needs to be. Now we're going to factor this thing, and what I'm going to do here is what I should have done in the previous problem. We had a 5 here in the previous problem, and I should have just factored the 5 out. But we're going to go ahead and mention that in this problem, and we're going to do that actually. So I'm going to factor out a 2 here. I'll pull 2 out. It's going to make life for us a whole lot easier. Right, so this would be 13x and then plus 40. So if you were to distribute this 2 back across, we should get 2x squared, right? Negative 26x, and then 2 times 40 is 80. Now this is what we're going to want to factor, and this is what I should have done in the last problem. And when I was making these problems up, I think that's what I intended to do. But it's been a while since I've done this. I think it was like a couple weeks ago or something. But anyway, now this is what we're going to want to focus in on factoring. So we know that we know that both of our factors, our first terms will be x. Okay. Now let's take a look at 40 over here. Let's break it down. We got 2 times 20, right? 2 times 20. We can also break this down to 4 times 5. And you can keep going like this. However, let's look at 8 and 5. Okay. 8 and 5 is 13, yeah. Minus 5 minus 8. Okay, so we have negative 5 times negative 8 is positive 40. And then when we add them together, we get a negative 13. Right? Yeah. And then, of course, we have the 2 outside here. See, things are a whole lot more difficult if you just try to factor it this way. Okay, pull out, if you got a common factor, pull that sucker out of there. That's what you want to do. Alright? And, okay, I think we're done with that. And anyway, I should have done that in the last problem, wasn't thinking. So 2 times x minus 5 and times x minus 8. Yeah, there you go. Alright. So we're over here at GoToMath.com practicing some factoring, and see you in the next problem. Hey, we're over here at GoToMath.com. Click on the algebra. Let's go down to Factoring Trinomials. And I believe we are 5.1. Yes. 5.1. Wait a minute. Wait a minute. I think we're doing 4.1. Look at something here real quick. I guess I was hoping we was doing 5.1. No, we're doing 4.1 it looks like. 4.1. Getting ahead of myself there. Yeah, it's got to be 4.1. I hope so. Okay, I got to write this down. 9x squared plus 18x plus 5. 4.1. Huh. Alright. Okay. So this one here, we can't factor anything out, like in the last problem. Okay. So 9, look at 9 over here, is either a 1 and a 9, or this is going to end up being a 3 and a 3, right? Good news is this can't, I mean, the only thing that goes into 5 is 1, so that's kind of the good news. I'm going to go ahead, we got to start somewhere. And I do know this, that since both these are positive, this is going to both be positive here. Okay. And so, what else we got going on here? Let's do, if I put a 3 here, we're going to get 27. And 27, yeah, that's not going to work. What if I put a 1 here and a 9 here? 9 times x is 9x squared. 9 times x times 1 is 9x. And then plus 9x. There's 18x. And then 9 times, oh, crud. 9 times 1 is not 5. So, that kind of narrows things down. I wasn't thinking. This is either going to have to be a 1 and a 5, or a 5 and a 1. Okay. Put a 5 here and a 1 here. So 9, then 5 is 14. No, that ain't going to work. Well, alright. We know that it's not, I didn't leave any room for myself. Well, then it has to be 3 and a 3, because there's no other choice. There's absolutely no other choice. You have 3 and 15. There you go. 3x times 3x is 9x squared. Then 3x times 1 is 3x. And 3x plus 15x is 18x. And then 5 times 1 is 5. Bam. How do you like that? How do you like those apples? 3x plus 1 times 3x plus 5. And let me look at something here real quick. And the way this is working is I guess because this is a smaller number than that, if you were trying to type that in, if you didn't know what order to type that sucker in up there. Okay, so there it goes. Trial and error sometimes. So we're over here at gotomath.com trying to figure it out. See you in the next problem. Okay, we're over here at gotomath.com. Click on the algebra. Let's go down to factoring trinomials and 4.2. Alright, 4.2. I got to write it down. 18x squared plus 27x minus 35. Question is, can we pull anything out of there before we actually start factoring? That's the question, and probably not. 18x squared plus 27x minus 35. Is there a number that will go into 18, 27, and 35? Well, we know that 35, might as well just go ahead and write that down now. There's, let's see, 5 times 7. And that's 2 and 9, so no. So, okay, that's terrible. But anyway, good news is it's just a 5 and a 7, so that kind of helps out a little bit. Alright, so I'm going to go ahead and also write 18 down over here. So we got 1 and 18. I should have wrote 1 and 35, huh? up here. We've got, what else we got? Let's see, I'm just going to write this down here. So we got 2 and 9. Yeah. I don't know. We're just going to start throwing some stuff out here. Start throwing some stuff out and see what happens. If I put a 5 here, maybe we might get lucky or something. Let's see, 2 times 7 is 14, and that's definitely not it, because that's a 45. But wait a minute, we got a minus sign here, and that means we're going to have a plus and a minus. Negative 14, 45. Let's see, 45 minus 14. Boy, I got a bad feeling on this one. That's 31. Okay. Let's get out the eraser here. And let's do 5 and 7. No, 7 times 9 is 63. That makes it worse. Boy, that ain't it. Oh my God. Hopefully I get this down sometime tomorrow, today. 1 and 18. I need to cross off what I'm doing here. Let's see. 3 and 3 and 2. That's 6 and 3. 6 and 3. Let's see, 12 and that's 27 right there. 6 and 2 is 12. Okay, but then let's see, what did I just do here? 54, 6 and 54. Oh, this is terrible. It's terrible, man. 18 and 1. Let's see. You know what? What if I did 35 here and 1 here? 18 and 35. Dadgum is 17. 18 and 35. You probably have already gotten it. I'm over here struggling. Let's see. 2, let's see, 9 and 2. 18. Did I already do that? 18, 35, and 18. Yeah, 17. Okay. Well, this times this is going to always be 18. What am I thinking? Oh, wait a minute. This times, what am I thinking? Crud. This has to be a 1 here. 9 and 35. Whoa, wait a minute. Wait a minute. No, it's 26. How could that happen to me? 9 times 1 is 9. Let's see, negative 9, 35. Wait a minute, something's not right here. This has got to be 18. This has got to be a 2 here. That's 18. That's 9. Oh, that's definitely can't be it. Man, this is terrible. Let's see. Um, oh my gosh. 6 and 3. Oh. Back, make sure I wrote the problem down right. 18x squared plus 27x minus 35. Okay, so go back and if I've done this or not. Let's see. 18, 6, and 3. Did I do this yet? 6 and 3. Shoot. One of these combinations has got to be it. Alright, let's see. 18, 35. How do you do that? 18 and 30. Wait a minute, I think I was multiplying this stuff wrong or something. 18, 6 times 3 is 18, and then 35. What? Minus. Plus. 6 times is 18x squared. It's minus 35. Oh, what the heck? 6 times 7 is 42 minus 15. Oh man, I think I was multiplying this stuff wrong. Okay. Oh, I'm not even believing this is happening. God, I about clicked on the calculus button up there. 3x plus 7 and 6x minus 5. I just got it written by the other way around. Oh my God, I didn't think I was ever going to find that. That is crazy. Okay, so we're over here at gotomath.com trying to figure it out. Alright, see you in the next problem. Okay, we're over here at gotomath.com. Click on the algebra. Let's go down to factoring trinomials. And hopefully we'll get this one figured out. Let's see, we're doing 5.1, right? Yep. That's it. I almost did 5.1 in the last problem. Okay, so we got negative 7x squared minus 33x. This doesn't look too bad. Plus 10. The last couple problems have been terrible. Trying to figure out. Alright, so we got negative 7x squared minus 33x and plus 10. So the first thing I'm going to go is, hey, can I factor, is there a common factor here? And 33, let's see, the prime factorization is 3 and 11, so no, obviously not. But what we can do is pull this negative out, okay? And we always want to do that. We don't ever want to have a negative coefficient out here. So let's definitely do that. Alright, so I'm going to go ahead and write this 10 over here. And so what do we got? Well, we got 1 and 10 and then 2 and 5. So that's good. There's only two possibilities there. And then of course we got this 7 up here. So we could either have 1 and a 7 or a 1 and a 7. So there you go. Okay, so it looks like we got two possibilities. Okay, so we don't have too many there we got to go through. And I'm going to write a 7x then here, and then x here, and let's see, got to get a 33. So 7x times a number, and plus this has got to be 33. Good news is, I didn't write that. Bad news is, good news is I caught that. Holy smokes, we factored out a negative, which is going to make that positive, positive, and that negative, and I just about didn't see that. Wow. Okay, so what do we got? We could put a 10 here and a 1 here. Now remember, this is a minus sign here, so one of these guys is going to have to be negative, right? It's going to have to be negative, but remember, we got a positive 33 here. And anyway, let's just look at this. We have 7 times 1 is 7, and no, that's not going to work. that is not going to work. But the good news is we don't have too many others to have to test. If I'd put the 10 here, that would be 70, and then the 1 here, that's definitely not going to work. So it's got to be the 2 and the 5. So let's just throw this in. 2 here, 5 here. 7 times 5 is 35. Aha. Let's make that a plus and that a minus. So 7 times 5 is 35. Minus 2 is 33. And negative 2 times positive 5 is negative 10. Wow, that wasn't as bad as the last problem, that's for sure. But then again, we didn't have as many possibilities to go through either. Okay, so let's go over here, click on the answer, and make sure here. Okay, now I noticed something in this problem here. Okay, we've got 2 minus 7x, and if you're wondering where that's coming from, what happened is we went ahead and multiplied the negative back across inside, even though this is definitely just as good, probably if not better, but we went ahead and multiplied the negative back inside, which is going to make that a negative 7x and a positive 2, but you would want to write it like this. Okay? See that? 2 minus 7x. So if you're wondering where this comes from, that's it. Okay. So we're over here at GoToMath.com, practicing some factoring, and see you in the next problem. Okay, we're over here at GoToMath.com. Click on the algebra. Let's go down to factoring trinomials. And we are looking at 5.2. 5.2. So let me write that down, 5.2. So we have 4x squared minus 17x plus 15. So you should be trying to work this thing out as fast as you humanly can. Alright, I got it written down. We're going to write it down again. 4x squared plus minus 17x and plus 15. So like I said, these things can be puzzles. There's no doubt about it. So we have a 1 and a 4 or a 2 and a 2, right? 2 times 2 is 4 or 1 times 4. So there's the possibilities of the coefficient there. And then we got 15 down here. So 1 and 15 or 3 and 5, which is good. Alright. And then, of course, we also want to look at, hey, can we factor a number out of all of this, maybe to simplify this thing down? And the only thing, it looks like the GCD is 1 of these two coefficients in this constant here. So, okay, no luck on that. All right, let's see. I'm going to write a 4x here. We'll start with that. Now, there is a systematic algorithm that you can actually use. I've been doing this, skip over here, no real algorithm in figuring this stuff out. But let's try to maybe come up with one. Okay, so we're going to use that, and then let's look at these guys here. How's that? Okay, and we want to get a 17. So I know that if I put 15 here, 4 times 15, that's going to be a little too big, isn't it? That's 60, and then a 1. But if I put 15 here, 1 here, let's do that. Let's put a 15 here and a 1 here. So that would be 4x and then 15, 4 and 15. I don't think we can muster up a 17 on that. So let's eliminate that guy. Now let's check 3 and 5. So 3 and 5. Now 4 and 5 is 20. And then you have a 3. And if we subtract 20 minus 3, we get 17. If we had... we got a positive. That means that both of these are going to have to be negative. Just seen that. And... darn it, because that would have gave us 17. See, that's negative 20 minus 3 is negative 23, and that's not going to work. Wow. So it's not going to be a 4 and a 1. It's got to be a 2 and a 2. Because we just went through all the possibilities, right? Wait a minute. I think, hold on before I jump to conclusions here. Let's put the 3 here just for the heck of it and the 5 here. So 4, that's negative 12. And negative 12 and 5 is negative 17, isn't it? Wow, I just about skipped the answer. So 4x minus 5 times x minus 3. Yeah, 4x times negative, that's negative 12. And then minus 5x is negative 17. And negative 5 times negative 3 is positive 15. So we just about bypassed the whole thing. That wouldn't have been good. And what's going on here? 5. Do we have a plus sign or a minus sign? 4x minus 5, x minus 3. Okay, I'm not exactly sure. 4x minus 5. I don't know why in the world I got it written like that, but I mean, it's equivalent, but the problem of it is I don't know. Just trying to mess with you, I guess. You know, you can factor out a negative here, factor out a negative here, and a negative times a negative is a positive, and you just end up with that. So that's kind of bizarre. They're both equivalent, but it's kind of bizarre the way this is written. But I mean, it's the answer, so there you go. Oh my gosh, we're over here at GoToMath.com having a great time. See you in the next problem, maybe. We're over here at GoToMath.com. Click on the algebra. Let's go down to factoring trinomials. And I believe we're at 6.1. 6.1. Okay, so let's write this down. Got x to the 4th plus 37x squared plus 36. Right. And we need to erase the last problem. Okay. X to the 4th plus 37x squared plus 36. In this particular technique here, we're going to be using a substitution method. And let me write it like this. Maybe you can better see it. So if I had x raised to the 2nd power, let's put parentheses around that and then raise that to the 2nd power. Now, powers, you multiply them together, and of course we would get 4, right? And then we'll just go ahead and rewrite this part. Alright, the substitution part is we're going to let x squared be, we'll let it be u. How's that? We'll let it be u. So then we can just, where there's an x squared, we'll put a u in there. Okay. Now that looks more like something that you should be able to factor up to this point now. Okay. So let's go ahead and do that. So we'll start with a u and then a u and close parentheses. So u times u is u squared. Now we need two numbers to multiply together. Let a and b be the two numbers. When multiplied together, we get 36, and then when we add a plus b, we get 37. So let's take a look at, let's break this 36 up. What about, what about 31 and 36? If you look at this, 1 plus 36 is 37, right? 1 times 36 is 36. So I think that's what we're going to do. That was pretty easy. A plus and a plus. Right, so we go back now, let's take a look at this, let's check. So u times u is u squared, then u times 36 is 36u, then 1 times u is 1u, and then 1 times 36 is 36. So we would add the u times 36, and then the 1u, that's 37u. Okay, that works out. But now, what the heck, what is this over here, right? What is that? Well, for where there's a u, we're just going to plug in an x squared. So x squared plus 1 and x squared plus 36. Now the question is, can we factor this guy and can we factor this one? And the answer to that is no. Okay. You can't find two linear terms here that multiply together that gives us, using real numbers anyway, that gives us x squared plus 1. And the same thing here. Now if this were a minus sign, then we could factor. This would be the difference of two squares, but it's not. It's not, right? So there you go. Okay, so let's go back to the page and see what we got here. We got x squared plus 36 and x squared plus 1. Right? Okay. Well, that takes care of that problem. So we're over here at GoToMath.com practicing on how to factor trinomials or just polynomials in general. And come on by, and I guess I'll see you in the next problem. Hey, we're over here at GoToMath.com. Click on the Algebra. Let's go down to Factoring Trinomials. We're over here, go to math.com, click on the algebra, let's go down to factoring trinomials. And I guess 7.1 we're doing. Okay. 7.1. So we have x to the fourth minus 80x squared minus 81. I think in the previous video we lost the audio part, and I just don't have time to go back and redo it. So I'm trying to get this algebra done in the month of March. It is time consuming like you don't even know. Very time consuming. We have x to the fourth, so hopefully we won't lose our audio in this one here. But there was a strange background noise on the computer, and I'm not exactly sure what that was, and I think it probably has something to do with that. Okay, so in the previous two problems, we worked with this trinomial that has a degree of 4 here, and so you should have an idea of what we need to be doing here. We're going to let x squared equal u and then do our substitution. So this becomes u squared minus 80u minus 81. Alright, and so once again we're looking for two numbers that we can multiply together to give us 81, and then when we add them we get 80. Now of course we have a minus sign right here, right? And one here, we got to take note of that. And so in other words, one of these a and b is going to be a negative. Okay, just one of them. Either a is negative or b is negative. And then the same thing, the larger number here is going to be the negative number if we're going to get that. I guess I should put that in there. It should be pretty important. So let's take a look at this. So first off, 81, right? 1 times 81 is 81. Could we put a 1 and an 81 in here to get 80? And obviously, the question that is yes, because 81 minus 1 is 80. Right, so let's do that. We'll put 81 here, 1 here, and then this is going to end up being the minus sign, and that'll be the plus. Okay, so look at here. U times u is u squared, u times 1 is 1u, and then minus 81u gives you minus 80, and then negative 81 times 1 is negative 81. Alright. Now let's go back and do the back substitution. We have x squared minus 81 and x squared plus 1. Okay? Now let's take a look at this. This x squared minus 9 squared. Right? 9 squared is 81. Now this is the difference of squares. And I think we worked some of these problems earlier. And so this can actually be factored as x minus 9 times x plus 9. And of course, we're not going to be able to factor that any. So we'll give that actually a name. You can't factor a polynomial, but we won't get into that right now. X minus 9, x plus 9, x squared plus 1. So let's take a look at what we got. X plus 9, x minus 9, x squared plus 1. They got a minus here and a plus here, but it doesn't matter. However, it will matter when you go to type it in up here. So looks like a plus sign will always be here and a minus here for this guy. Sorry about that. Okay, ends that problem. Or over here, go to math.com, practicing how to factor. Come on by, see you in the next problem. Okay, we're over here at gotomath.com. Click on the algebra. Let's go down to factoring trinomials. 7.2. Those are nasty numbers. Oh man, they're just getting worse. Okay, let's cheat and use that one. So we're at 7.2. This is x to the fourth minus 50x squared plus 49. Alright, bringing up the whiteboard. We have x to the fourth minus 50x squared plus 49. So once again, we're going to use substitution. Alright, we're going to let u equal x squared. So we got u squared minus 50u plus 49. And if you're wondering why there's a 2 here, because remember we can write this x to the fourth as x squared raised to the second power. So we're substituting this x squared right in here for a u, and then it becomes u to the second power. Okay, so I thought I would I know I mentioned that earlier, but you might have forgotten. Now, we're looking for two numbers, and we multiply them together, we get 49, and when we add them, a plus b is equal to negative 50, let's say. Okay, so let's take a look at 49. So 1 times 49 is 49, and then if I had a minus 1 and a minus 49, when we add them together we get minus 50. So I believe that's what we're going to do. Minus 1 u minus 49. Right? U times u is u squared. U times negative 49 is negative 49u. Minus 1 times u is negative 1u. So we add both those together and we get negative 50u. And negative 1 times negative 49 is positive 49. And now we'll go back and do the back substitution. X squared minus 1. Substitute x squared back in. Okay. Well, we have a difference of squares here. So this becomes x minus 1 times x plus 1. We can factor that. And a difference of squares here, right? 49, or 7 squared is 49. So x minus 7 times x plus 7. There you go. Completely factored. Now, wasn't that fun? Alright, let's go in here. Tell them what kind of order I got set up. Right, x plus 1, x minus 1, x plus 7, x minus 7. There you go. Alright. So we're over here at gotomath.com practicing how to factor. See you in the next problem. Okay, we're over here at gotomath.com. Click on the algebra. Let's go down to factoring trinomials. And I guess we're looking at 8.1 this time. 8.1. So we have 5x squared plus 10xy. Whoa, we've got another variable in this problem other than just x. Okay, so let's write that out. 5x squared plus 10xy, looks like a G, plus 5y squared. Let's make that look more like a y here. Okay. Now, if you notice, take a look at these coefficients here. 5 goes into all these, right? So we're going to pull a 5 out. I think that's just a distraction. Okay. Alright, well, how in the world are we going to factor this guy? How about if we did x plus y times x plus y? What about that? Will that work? Let's take a look at it. X times x is x squared, and x times y is xy. Y times x is yx. Now those are both xy and then yx. These are both like terms, so we can actually combine that to 2xy. And I see a mistake I made. Actually, that 10 does go there. That's supposed to be a 2 right there. I'm like looking at that going, oh boy, that's not there. We pulled the 5 out, right? Okay, 5 goes into 5 one time, 5 goes into 10 two times, 5 goes into 5 one time. Okay. All right. Now, there we go. And then, of course, we got y times y is y squared. Now, another way of writing this, actually, since both of these terms are the same, you can just combine them, put them with the power of 2. However, I think I write them, the answer, like this. So let's take a look at that. There it is. Okay. Alright, it's not too bad. Just practice on that. So we're over here at GoToMath.com, practicing factoring trinomials. Come on by, and I'll see you in the next problem. Hey, we're over here at GoToMath.com. Click on the algebra. Let's go down to factoring trinomials. And you know what? I'll just push the button here. Whoa, 8.2 comes up. So what we're looking at, 8.2. So we have x squared minus 5xy minus 6y squared. This looks like this might be a little bit more trickier than the last problem. Tricky. So x squared minus 5xy minus 6y squared. Okay. So we know that both these terms are going to start with an x, because x times x is x squared. But now we have this negative 6 and this negative 5, right? But this last term here is a y squared. So we know that there must be a y here and a y here, because y times y is y squared. So really all we're looking at is the same thing we've seen in the past, where we multiply two numbers together and we're going to get negative 6, and then when we add them we're going to get that negative 5 there. So 6 is not too bad. Let's take a look at it. So 1 and 6, right? Now, because this is a minus sign here, one of these can only be negative. Right, so either negative 1's or 1's negative or 6 is negative. And let's see. Okay, what about if this were negative? Right, 6 is negative, because then 1 minus 6 is negative 5, and 1 times negative 6 is negative 6. So there you go. Okay, so we'll let this be the 1. We'll put the 1 here, even though we're not going to write it. 1 times y is y, and then we'll say minus 6 over here. How's that? So x times x is x squared, then you have x times negative 6 xy plus y, that's going to give us negative 5xy, and then y times negative 6y is negative 6y squared. There you go. There it is. X minus 6y and x plus y. Even though it's written in a different order, same thing. Same thing. Okay, we're over here at gotomath.com. You can come on by. See you in the next problem. Okay, we're here at gotomath.com. Click on the algebra. Let's go down to factoring trinomials. We're down here at 9.1. Ooh, lovely. That looks lovely. We got an x, y, and a z. Oh boy. So 10x squared plus 20xy z plus 10y squared z squared. This ought to be fun. Hope I can work it out. I don't know, we're going to find out. So we have 10x squared plus 20xy z plus, of course these are all separate variables, right? X times y times z. Okay, thought I'd throw that in there. And then 10y squared z squared. Now before we really get started here, what we need to think about is can we factor a number out? And it looks like we can pull 10 out of here. So let's do that. So that becomes x squared plus 2xy z plus y squared z squared. Okay. So we got a y squared and a z squared. That ought to be some kind of clue. And we have an x squared. So we know that these first two terms here is starting off with just x, because x times x is x squared. And then these guys right here, because they're y squared and z squared, I'm thinking we should put a y here, z here. Let's do plus. And then a y and a z, because y times y is y squared and z times z is z squared. So we have x times x is x squared, x times yz, and then yz times x. So that means there's two of those are like terms. So we just add them together and then multiply the last ones there. Right. Now, of course, I should add that you could write it like this to condense it down if you wanted to, but we're going to completely factor it out here. Alright, but that should be noted. Needs to be stated, I guess. X plus yz, x plus yz, and factored out to 10. Alright, hopefully you're getting the hang of this stuff. I know I am. Okay, so we're done with that. Come on over and check it out. See you in the next problem. Okay, we're over here at gotomath.com. Click on the algebra. Let's go down to factoring trinomials. And we're looking at 9.2. There. We can get it to come up. So let's write that down. We got x squared minus 4xyz minus 5x squared z squared. And write that out. 4xyz minus 5x squared z squared. So the first thing we're going to do here is, can we factor out any of these coefficients? And it doesn't look like it. Okay, so that's going to be the first thing I'll look at. Well, because this is x squared here, I know that these first two terms here are going to be just x, because x times x is x squared. Now let's take a look at these guys. We have an x squared and a z squared. Actually, you know what? We could actually factor out. Did I write this problem down right? No. That's a y squared. I thought something was fishy there. A y squared. Huh. I'm like going, man, something is not right here. Okay. So I could put, let's see, we'll put a y here, a z here, a y, and a z, because y times y is y squared, z times z is z squared, right? But once again, we're looking for two numbers that when multiplied together gives us -5, and then when we add them, we get -4 here. Okay. Well, the only two numbers to multiply together that gives us -5 is going to be a 1 and a 5. So that ought to be pretty easy to figure out. So it looks like this is going to be the minus here, because 1 minus 5 is -4. Right. So we'll let this be the 1. This is a lot like the last problem. And then -5. Minus 5 there. Okay. And it doesn't look like we can do anything else with that. So we got x minus 5yz, x plus yz, x plus yz, x minus 5yz. Okay, just written in a different order, but it's the same thing. Same thing. Alright, we're over here at GoToMath.com. Come on by, practice. See you there. See you in the next problem, maybe. We're over here at GoToMath.com. Click on the algebra. Let's go down to factoring trinomials. And I guess we're looking at 10.1 now. Whoa, what is all that? I don't know. We're going to find out here in a minute. This is x cubed y to the 4th plus, and of course we got to have the cursor in the way, 10x cubed y squared plus 9x cubed. Got it. Got something anyway. Alright, so let's rewrite this. X cubed y to the 4th plus 10x cubed y squared plus 9x cubed. Okay. So taking a look at the coefficients, I want to look at that first. Can we factor anything out? And no. Alright, the GCD is 1, so we can't factor anything out on that. But look at here, we got something going on. We got an x cubed, and an x cubed. Huh. So I'm thinking we can factor out that x cubed. And we're going to do that. So let's do that. So we have y to the 4th plus 10y squared plus 9. Oh man, another one of these problems. So the degree is 4, and that means we're going to be using some substitution. And I don't know why I wrote x there. So we're going to let y squared equal u. We're going to let u equal y squared, however you want to say that. Okay, so I'm going to go ahead and rewrite this x cubed here. And so we have u squared plus 10u plus 9. Plus 9. Okay? Now remember, we're looking for two numbers. When multiplied together gives us 9. And I almost wrote a plus sign again. I did that in an earlier problem. Getting ahead of myself or something. So a plus b is equal to 10. So what do we got? Well, what about a 1 and a 9? Because 1 times 9 is 9, and 1 plus 9 is 10. There you go. What do you know? There you go. And I guess I should have done this already. Alright, so we'll let this be 1 and that be 9. U times U is U squared, then we have U times 9 is 9U, 1U, so that makes that a 10U. What's going on here? Something, it's not major, but it should have been done there. Forgot to do that. 10U and then 1 times 9 is 9, right? Now we go back, substitute back in our y. So we got y squared, and then we have y squared plus 9, and I believe we're done. We can't factor that any more. That's it. Alright, let's take a look at what the answer shows. Y squared plus 9. Okay, so x cubed, y squared plus 9, y squared plus 1. And of course, I would write those in a different order as usual, but it's all the same. Okay. Alright, we're over here at GoToMath.com practicing factoring our trinomials. Come on by, check it out, see you later. You know the rest. Okay, we're over here at GoToMath.com. Click on the algebra. Let's go down to factoring trinomials. I think we got one more problem left in this section for now. I'm always glad. What the heck is all that? That looks like a headache. So x to the 4th, y to the 4th, z to the 4th, oh my god, minus 65, x to the 4th, y to the 4th, and z squared. That's kind of weird. We got, wait a minute, z to the 4th, oh my god, minus 64, x to the 4th, y to the 4th. Alright, x to the 4th, y to the 4th, z to the 4th, minus 65x to the 4th, y to the 4th, z squared minus 64x to the 4th, y to the 4th. That's enough to make me dizzy. Fortunately, we got to write all this stuff out now. So we got x to the 4th. I was just writing it down. Y to the 4th. Z to the 4th. And then there's the 4th of July now. Of course, that may not mean anything for some people watching this. Let's see. 65. X to the 4th. Actually, the majority of the people. Y to the 4th, z squared minus 64 x to the 4th, y to the 4th. A lot of 4th going on there. Okay, so what can we pull out of this thing? We have an x to the 4th, x to the 4th, x to the 4th. And, well, look at here. We got a y in each one of these terms, too. Okay, I think that's going to help out. We're going to pull out an x to the 4th and a y to the 4th. Isn't that great? And so we're going to be left with z to the 4th minus 65 z squared minus 64. Okay, I think that helps out quite a bit. So once again, we're going to have to do the substitution. We're going to let z squared equal u. Okay? So this is going to become u squared minus 65u minus 64. And then this is x to the 4th, y to the 4th. Okay? So once again, we're looking for two numbers that when multiplied together gives us negative 64, and then of course when we add them we get negative 65. Seems like we did this earlier, and I hope there's no mistakes, but I got a bad feeling I don't want to work this problem again. 1 and 64. Oh man, is that supposed to be a plus sign? Huh. That's not possible. Ah, darn, this chap's my, you know what? I think this is supposed to be a plus right here. In fact, I'm positive. Right, that would give negative 65, and then that would be a positive 64. Okay, we're not redoing this problem. I'm exhausted. So that should be a plus sign. I'll go in and change the coding there. Okay. Yeah, I'm not going to redo this problem. I ran into this earlier with a problem similar. Of course, you didn't see it because I deleted out the video and redid it over again. Alright, what are we doing here? So we got minus 1 and then minus 64. So u times u is u squared, u times negative 64 is negative 64u minus u is negative 65u, and then we have a minus 1 and minus 64, multiply them together and you get positive 64. And now we go back and we're using z, aren't we? Yeah, sorry about that. But that's the way things are sometimes. So we're using z, so this should be z squared, and then this is going to be z squared minus. Now, I'm not going to write 64. What I'm going to write is 8 squared here. Okay, and 8 squared is 64. But what we got going on here is we got a difference of squares here. So we have x to the fourth, y to the fourth. We're going to have z minus 1, z plus 1, z minus 8, and then z plus 8. Okay? So we got going on there. And I'm sure the answer is correct. Yeah, see that? So that should be a plus sign. I'll go in and change that. But z plus 1, z minus 1, z plus 8, z minus 8, and x to the fourth, y to the fourth. Got it. Alright, we're over here at GoToMath.com, finding mistakes. Alright, well that ends this section, and I guess I'll see you into the next section. And alright, see you later.